So the last section that we are looking at involves solving linear systems in 3 variables. We've looked at linear systems with 2 variables, we've looked at linear inequalities. The solving by substitution with a system of 3 or more variables is extremely challenging because you'd have to get 2 of the equations solved for in terms of the same variable. So 99% of the time you're going to end up with fractions. So we are just going to learn how to solve a system with 3 variables by elimination. And the way that we do that is we have to use elimination over and over until we end up with just one variable and we can solve. So I'm going to start by using elimination with my first 2 equations because I noticed that one has a positive z and one has a negative z, so that z will cancel right away. So I'm just going to add the equations. X plus 2x gives me 3x, 2y plus y gives me 3y. My z's cancel, 8 plus 4 is 12. So now what I want to do is use 2 different equations, get my z to cancel, so then I have 2 equations with 2 variables and I can solve by elimination again. So I'm going to go ahead and use my second 2, and I'm going to multiply my second equation by 3. So I've got 6x plus 3y minus 3z equals 12. And then my third equation, so that when I add these 2 together, I'm going to write my answer under the red one. 6x plus x gives me 7x. 3y plus y gives me 4y. Again, my z's cancel. 12 plus 7 is 19. So now I can use elimination on these 2. And I'm going to go ahead and cancel my y's. So I'm going to multiply my first equation by negative 4 and my second equation by 3. So we've got negative 12x minus 12y equals negative 48. And 21x plus 12y equals 57. So adding these 2 equations together, my y's cancel. I get 9x equals 9, nice enough, so x equals 1. And then what we have to do is back substitute to solve for y and z. So I can use either my red or my green equations here to solve for y. I'm going to go ahead and use my red equation, it's got some smaller numbers. So substituting 1 for x, I get 3 plus 3y equals 12. Subtracting 3 and dividing by 3, I get y equals 3. And then I can use any one of my original equations to solve for z. I'm going to go ahead and use the first one, substituting 1 for x, plus 3 for y. 1 plus 6 is 7, subtracting that from both sides. I get z is 1. So we want to write our final answer as an ordered triple. Obviously we're going to go in alphabetical order, x, y, z. We'll take a look at one more just for some extra practice. So looking at this one, I'm thinking I'll probably cancel z again. My first and second equations, I've got opposite signs on my z's. So if I multiply my first equation by 3, and then eliminate it with my second one, so I have 12x plus 3y minus 3z equals 126. Negative 2x plus 2y, just rewriting my second equation. Now I get my z's to cancel, I get 10x plus 5y equals 100. So now I need to use 2 different equations and get the same variable to cancel. So I'll use my first and my third. By the way, I'm looking at this now, and I don't want to re-record the whole video, but it would have been a lot easier to eliminate x. So I'm going to use my first and my third equations, multiplying this by 5. I get 20x plus 5y minus 5z equals 210. And my third equation, adding these together, I'm going to go ahead and write the answer underneath my red one because those are the 2 I'm going to use to eliminate again. So I've got 22x plus 2y equals 220. So choosing a variable to eliminate, I'm going to go with my y's. So I'm going to multiply this equation by -2 and this one by 5. So we get -20x minus 10y equals -200. And our second one, 110x plus 10y equals, adding these together, and dividing both sides by 90, I get x equals 10. So again, I'm going to back substitute into either my red or my green equations right here, either one, to solve for y. I'm going to use my red equation, so we've got 10 times 10 plus 5y equals 100. Subtracting 100 from both sides, dividing by 5, y equals 0. So going back into any one of my original 3 equations, solving for z, I'm going to go ahead and use my first equation here, substituting 10 for x, 0 for y, adding z and subtracting 42 from both sides, we get z is -2. Writing our answer still is an ordered triple. Remember, 0 is a legitimate answer, so we need to include that as part of our solution. So x, y, z is our solution. And your U-try problem. Try and look at it a little more carefully than I looked at that second one and find the easiest variable to solve for first.